Hello future doctors, welcome to MEMONEET. How are you all? I hope all of you are having a good day and the preparation is going good as well. So welcome to MEMONEET. I am Aprajita, your chemistry SME, and I welcome you to another amazing lecture. So before we start with the session, so tell me, how's your day going on? How is the preparation going on? Are you facing any issues with your preparation? So stay students, you can interact with us. You can tell whatever problems you are facing. If you are having any issues or any queries, you can interact with us, right? So you can join the Telegram channel. There we are all present. All your SMEs are present who can answer your queries. All right. Or else you can respond in the comment section. So as I always say, today also I am saying, if you are having any problem, so do comment in the YouTube comment section. So tell me ki ma'am, we are facing issue in this topic. So we will make a separate video on that topic to make it understand to you, okay? Because that is something very important. Ki before you appear for the examination, all the concepts are clear. So the concepts will be clear only when you are telling us your problems, okay? So please do comment ki if you are having any problem in this particular question or in this particular topic. So let me know. I will separately design a lecture for that particular topic only, okay? It can be a small topic, it can be a big topic as well, okay? But you people need to comment. So comment section looks very empty actually. So I want my students to be interactive, okay, to tell me whatever issues they are facing. Or if you are liking the lectures also, you can also tell me, ma'am, yes, everything is understood, okay? So that will let me know ki yes, you people are actually understanding what I am teaching. All right. So that's the thing I want you people to do. So if you have any problems also, please do comment in there. All right. Okay, so as you can see that our today's topic is chemical kinetics. So BPT 8, which is on Sunday, we are having two chapters in that. So we have kept two chapters here because these two are small chapters and easy ones as well. Okay, so the first chapter was redox reactions that you have already done. If anyone has not watched the video yet, please go to the chemistry playlist and watch the redox reaction. There I have completed the whole chapter, and I told you also, yes, वहाँ पर balancing है, right? Balancing of redox reactions. If in that case you are having any issue, so you can comment there कि ma'am, please explain balancing once again. So I will take some examples and I will explain balancing once again. But only if you tell me कि ma'am, we have a problem in that. Okay? So please do comment. So please watch that. And the second chapter that we are having is chemical kinetics. So I'll be covering it in two lectures. So this is part 1 today, where we will be learning what is chemical kinetics, what are the basic terms that we use in chemical kinetics, okay? Because when I used to study this chapter, I used to like found it very interesting. Physical chemistry ka very, like, it's a very interesting chapter, and I think it's an easy one also, because yahan par you just have to memorize the formulas and everything, and yeah, rest everything would be done, okay? And the syllabus is also not that much, topics bhi zyada nahi hai, so it's an easy but a scoring chapter. You get a lot of good questions from chemical kinetics in Neet exam, so it's a scoring chapter as well, okay? So that's why please focus on it, and let us start with the very first thing. So as I told you, first thing is introduction. So if I talk about chemical reactions or chemistry, so we know that here substances with well-defined properties are converted by chemical reactions into other substances with some other properties, okay? So for any chemical reaction, what we are trying to find out? Chemists try to find out the feasibility of the reaction. Means we want to see whether the reaction is feasible or not. Means whether the reaction will take place or not. So how do we check the feasibility? By thermodynamics, we have studied now that if the delta G naught is less than 0, then the reaction is spontaneous or it is feasible. So that's what we check by thermodynamics. Next is extent to which a reaction will proceed. कि किस extent तक that particular reaction will go, that we check from chemical equilibrium, that we are going to study, okay, after that. Next is speed of reaction. Speed of reaction means time taken by the reaction to reach the equilibrium. Now, how do we check what speed the reaction will take place? Like, will it be a very fast reaction or is it going to be a slow reaction? So, along with the feasibility and extent, it is equally important to know about the rate of the reaction. Speed को हम बोल सकते हैं, we can call it as rate of the reaction as well, and factors controlling the rate. On what factors that speed of the reaction will depend. Means if there is a very slow reaction, how can I increase the speed of that particular reaction, right? So that's what we need to know. अब वो सब कहाँ से पता चलेगा? वो सब पता चलेगा from chemical kinetics. So study of rate of reactions and factors affecting it. Okay, that is the temperature, pressure, catalyst, additions. So all this comes under chemical kinetics. So basic clear हुआ, right? If like I am saying कि if we are studying the chapter for the first time, तो kinetics का मतलब क्या है? What do we study in chemical kinetics? We study the rate of the reactions, okay, and factors affecting them. कि what are the factors that will affect? Okay. So not just the speed of the reaction, but we also describe the conditions under which the reaction rates can be altered. Like concentration, temperature, pressure, catalyst, they will change the speed of the reaction. Okay. So I think introduction is clear. What is chemical kinetics? Now you will not wonder ki ma'am, what is chemical kinetics? What the hell we are studying in that, right? So I think this is pretty clear. So now what do we understand by rate of a chemical reaction? So we are talking rate, right? Like what is rate of reactions? Rate of reaction means the speed at which the reaction is proceeding. So some reactions such as ionic reactions, they occur very fast. Like if I am having silver chloride, so if I am mixing silver nitrate and sodium chloride, so of course it's an ionic reaction. So यहाँ पर जो silver chloride है, it will get precipitated out and sodium nitrate. So this reaction is a very fast reaction, okay? And very fast reactions cannot be studied by kinetics. They can be studied by flash photolysis on everything, okay? And on the other hand, we have some very slow reactions also. Like fast reactions means that take just 10 to the power minus 14 to 10 to the power minus 16 seconds to happen. Means as soon as you mix it, precipitation will happen, okay? We can't study such fast reactions also by chemical kinetics, okay? But then we have slow reactions, rusting of iron in the presence of air and moisture. That also we are not studying by kinetics. But there are some moderate reactions. There are reactions that proceed with a moderate speed, like inversion of cane sugar, hydrolysis of starch. These reactions will be studied by chemical kinetics. Okay. Now, how do we define the speed of reaction? Speed or rate of reaction can be defined as the change in concentration of the reactant or product in unit time. Means we are taking a particular amount of time in unit time. एक unit time में how much concentration of the reactant or product is changing. So obviously what will happen, students? See, reactants change into product. Okay. Try to understand this. जैसे जैसे time will go on, like if the time is elapsing, okay, with the time, what will happen to the reactant? Reactant की concentration will start to decrease, na? Because reactants are getting consumed in the reaction and they are changing to product. So it means the concentration of the reactants will decrease with time, whereas the concentration of the product will increase with time. Right? So how can we tell the rate of reaction? So we can say the rate of decrease in concentration of any one of the reactants or the rate in increase in concentration of any one of the product. So that's what we will be telling in the rate of reaction. Okay. Now to understand it more specifically, let's say we have a hypothetical reaction. Reactant is changing to product and assuming that volume of the system remains constant. Now here what we can see from the equation ki 1 mole of reactant R is giving you 1 mole of product B. Now let's say at time t1 T1 कुछ टाइम था, उस पे रिएक्टेंट की कंसंट्रेशन वाज R1. सी हमेशा, नाउ इफ यू नो, कंसंट्रेशन को वी रिप्रेजेंट इन स्क्वायर ब्रैकेट. सो व्हेन आई एम प्रेजेंटिंग स्क्वायर ब्रैकेट, दिस स्क्वायर ब्रैकेट मींस आई एम टेलिंग अबाउट द कंसंट्रेशन. Okay, so R1 is the concentration of reactant and P1 is the concentration of product at time T1, whereas at time T2, R2 is the concentration of reactant and P2 is the concentration of product. Okay, so delta T means if I am talking about the change in time interval, so us change may, like in that particular time interval from T1 to T2, how much concentration has changed. So I will say it will be R2 minus R1 or P2 minus P1. So that I can say as delta R or delta P, means change in concentration of reactants or change in concentration of the products. Okay. So now the thing is, what we will see here is the rate of disappearance of R, कि R जो है वो किस rate पर disappear हो रहा है, at what rate R is disappearing. Okay. So rate of disappearance of R means the decrease in concentration of R. Up if decrease is happening, see rate of the reaction will always be positive. Up delta R जो है, this is delta R. Okay, so its delta R is a negative quantity. So to make the rate positive, I introduce a minus. क्योंकि the concentration of the reactant is decreasing. Okay. So it is equal to minus delta R by T, and rate of appearance of P will be positive delta P by T. Okay. So that's what we say that the rate of reaction is. Okay, so this is the rate of reaction. All right. Now these equations that we are using, let's say equation 1 and equation 2 that we are using, they are representing the average rate of reaction. Okay. Average rate of reaction, we can say R average. Okay. Now average rate of reaction का क्या मतलब हुआ? What do we mean by average rate of reaction? The meaning is that average rate actually depends on the change in concentration of reactants and products for that particular time taken. Okay, so actually we are taking a particular time interval, and in that whatever is the average change of reactants concentration and average change in concentration of the product that we are taking, so that we will say is the average rate of reaction. Okay. So what we will be doing, we will be dividing the total change in concentration of reactant and product कि total कितना change हुआ है. Okay, we will divide that with the time interval, so we will get the average rate of reaction. So you can see this is for the concentration of reactant. So graph is like this because concentration of reactant changes with time, and for product, concentration of products are increasing with time. Okay, so यहाँ पे like if I want to calculate R average for this particular time interval T2 and T1, so it will be minus delta R upon delta T. So delta R क्या होगा? R2 minus R1. Okay, R2 minus R1 upon T2 minus T1. Okay, so that is the average, and यहाँ पर भी आप देख सकते हो P2 minus P1 and T2 minus T1. Now if I talk about instantaneous rate of reaction that I want to talk about. Okay, I'll tell you the units also, but let's say if I'm talking about instantaneous. So this average rate of the reaction is used to tell for a particular time interval what is the change in concentration of reactant. But if I ask you, let's say if time at 5 seconds or if T at 10 seconds, at that particular instant, what is the reaction rate of the reaction? Of course, rate will also change now. So we are average rate means for, let's say we are taking for time T2 and T1 na. So let's say it is 10 seconds. So I'm saying ki for first 10 seconds the rate of reaction is this. But if I want to calculate the rate at the 7th second or the 5th second, then this average rate cannot be used, right? So in that case we will be using the instantaneous rate of reaction. Okay. Alright, so instantaneous rate means when we are considering the average rate at small interval of time, let's say dt, and when delta t approaches. So here we can see that it is minus dr upon dt and dp upon dt, where it is dr or dt, they are the small changes. Okay. So how can you find out the instantaneous rate from the graph? So from, like, this is a graph, you can draw the tangent at that particular instant. Like if I want to calculate the instantaneous rate at t 600 seconds, so I will draw a tangent at 600, okay, at that point, and then I can find out the rate by the slope. So this is the slope only, right? So I can calculate the slope, okay, and I can like extrapolate this. So यहाँ पर what will be the values t r1 and r2, and I say from t1 and t2 you can calculate the rate of the reaction. Now if I talk about the units of rate of reaction, so this is something very important. Your rate of reactions के unit जो होंगे time inverse, okay, it will be time inverse. For example, see why I am saying that it is time inverse, because rate is concentration per unit time. Okay. So rate is concentration per unit time. So concentration into time inverse we are saying. So concentration, let's say if it is in mole per liter and time is in per second, so the rate will be mole per liter per second. That will be the unit. Okay. Okay, students, now let us see how to represent the rate of the reaction. Okay, so here we are having a particular reaction. Okay, Hg plus Cl2 give HgCl2. So यहाँ पे आप देखो that in this particular reaction, the stoichiometric coefficients of reactants and products are same, like 1 1 1 होगा. So the rate of reaction will be minus delta Hg. Okay, like इसको ऐसे लिखना है upon T, ऐसे minus delta chlorine and minus, sorry, it will be plus ना delta HgCl2 because it's the product. Okay, so rate of reaction क्या होगा? Rate of disappearance of reactant, and this is rate of disappearance of reactant है ना, which is mercury and chlorine, which will be equal to rate of appearance of product. So square brackets represent concentration, keep that in mind. Okay. So यहाँ पर आप बोल सकते हो when the stoichiometric coefficients are same, the rate of disappearance of any reactant is same as the rate of appearance of product. But let's say if the stoichiometric coefficients are not same, what will happen? So if I am having 2Hi gives H2 and I2. अब यहाँ पर the coefficients are not same. Okay. So for representing such reactions where the stoichiometric coefficients are actually not equal to 1, so rate of disappearance of reactant or rate of appearance of product is divided by their respective stoichiometric coefficient. Like rate of the reaction for this reaction will be minus 1 by 2 delta Hi, okay, upon delta T. So why I have written 2 here? I have divided this 2 because the coefficient was 2 in this case. ऐसे for products it will be delta H2, यहाँ पर minus आएगा. Okay, and again delta I2 upon T. Okay, that's what you can say. Now similarly for this reaction, so for यहाँ पर bromide ion the concentration इसके साथ 5 is there, so it's minus 1 by 5 delta Br negative upon delta T. Okay, ऐसे यहाँ पर क्या होगा minus delta BrO3 upon T, and यहाँ पर minus 1 by 6 delta H upon delta T, and यहाँ पर positive 1 by 3 delta Br2 upon delta T, and here positive 1 by 3 delta of H2 upon delta T. Means I want to tell you कि if the stoichiometric coefficients are present, what will you do? You will divide the rate expression by that stoichiometric coefficient. Now, you know, in gaseous reactions, they occur at constant temperature. So, concentration is directly proportional to partial pressure of the species. Okay. So, in that case, we will be using the partial pressure instead of concentrations. Okay. Now, what are the factors that affect rate of reaction? Firstly, we will be talking about the concentration in detail. So, the rate of chemical reaction at given temperature may depend on the concentration of one or more reactants or the products. So, is representation ko ab now the rate of reaction is dependent on concentration of reactant or product. So, how do we represent it? Okay, how do we represent it? It's known as the rate law, rate equation, or rate expression, anything you can say. Okay. Now you know कि rate of the reaction decreases with passage of time. क्यों? Because the rate concentration of reactant decreases, right? Conversely, rate will increase when the reaction concentration increase. So the rate of reaction है that depends on the concentration of reactant. Keep that in mind. Now what is this rate law? Let's say if I'm having a reaction, A plus B gives C plus D. Okay, so rate of the reaction will be directly proportional to A raised to the power X, B raised to the power Y. Now what is this X and Y? X and Y can be or cannot be equal to the stoichiometric coefficients. It can be A and B also. It cannot. It's not necessary. ठीक है, समझ में आ रहा है? Of course we will write like A and B, but it is not necessary कि it is equal to the stoichiometric coefficient. It may or may not be equal. Okay, so if it is directly proportional, we will say rate is equal to K. A proportionality sign will get removed. So AX BY. Now what is rate of reaction? Rate of reaction is change in concentration of reactant upon time. So K into AX BY. Okay. So this is the rate law that we are getting. Now what is this K? K is the proportionality constant, which we call as the rate constant. Okay. So this is your rate law expression. So rate law expression is the expression where rate reaction rate is in the terms of molar concentration of reactants with each term raised to some power, and that power may or may not be same as the stoichiometric coefficient of the reacting species in a balanced chemical equation. Okay, same हो भी सकता है and नहीं भी हो सकता है. For example, if I'm having this reaction, so यहाँ पर rate is equal to K NO square. So यहाँ पर it's equal to the stoichiometric coefficient and O2 raised to power 1. यहाँ पर equal है. But if let's see in this reaction, you see rate is K into concentration of CHCl3 into chlorine raised to the power half. But here coefficient is not half. So in these reactions, is maybe and in the second one also, the exponent of concentration terms are not equal to the stoichiometric coefficients. Okay. So it means कि we cannot tell or predict the rate law just by looking at the reaction. Okay, it is not a theoretical concept, but it must be determined experimentally. We cannot tell कि यहाँ पर rate जो होगा it's concentration of CHCl3 raised to power 1 and chlorine raised to power 1. No, experimental says that it is chlorine raised to the power half. So this rate law is determined experimentally. Okay. I think it's clear. Now another important topic. So this is again an important topic, order of reaction, क्योंकि यहाँ से NEET में questions are asked mostly. Okay, because order of reaction is important. Now this is the rate law. Okay, this is your rate law. K into A raised to the power X, B raised to the power Y. Now X tells us how sensitive the rate is to change in concentration of A and B. Means what? How the concentration of A and B will affect the rate of the reaction. Means will it be square or will it be 3 times or 1 time, like that. So the sum of these exponents, okay, sum of these exponents give the order of reaction. Very easy. If you know the rate law, okay, if you know the rate law expression for any particular reaction, you can easily tell the order of the reaction, okay. So you can say that sum of powers of concentration of reactant in the rate law expression is called order of that reaction. Now this order of the reaction, student, can be 0 also, okay. Yes, 0 order reactions are there, 1 also, 2 also, so on, and even a fraction, okay. It's not like that it has to be a whole number, it can be a fraction also. Let's do a question then, okay. So first part I will do, second part you will do, and you will tell me the answer in the comment section. Please note, okay, comment your answer. So you just have to comment the answer ki order of the reaction is this, okay. Let me see how many of you will do it. Only 2 to 3 people are doing it, so I want a lot of comments, because see, if 200 people are watching it, so I want at least 200 comments, okay. Means all of you should comment this. So now let's say if I'm having this rate law k a raised to the power 1 by 2 and b raised to the power 3 by 2. So order means the sum of these powers of the concentration of reactant. So sum of powers is 1 by 2 plus 3 by 2. So ये कितना बन गया? It will be equal to 4 by 2 and that's 2. So it means the order of the reaction is 2. Okay. And remember, you have to tell me the answer for the second part. Alright. What will be the order of this reaction? You just have to add the powers only. Alright, students. So now these are the important terms that we need to know when we are studying kinetics of any reaction, okay? Alright, so now if I am talking about a reaction, so you should know, students, ki whenever we are writing a balanced equation, it is not telling us everything about the reaction, okay? Because it's not necessary ki reaction will be completed in one step only. It can take more than one step. Some intermediates will be formed, okay. Some transition states will be formed. So reaction jo hai, it will not be completed in one step. So you must know this difference. This is again important. It can be asked in the exam also. Very, very important. The reaction taking place in one step are called elementary reactions. Okay. So जो एक step में reactions होते हैं, we call them as elementary reactions. Whereas the reactions that take place in more than one step, मतलब बहुत सारे elementary reactions मिलके हमें एक product दें, we call them as complex reactions. Okay. Means when a sequence of elementary reactions give us the products, they are called as complex reactions. Okay. Now very important, listen to me carefully for next 2 to 3 minutes. Units of rate constant. This question is directly asked in Neet exam, okay, ki what will be the unit of this reaction? This is a first order reaction or this is a second order reaction. So you need to know the units of rate constant K. Okay, so how you are going to find out the units of rate constant K? So like for a reaction, this one, the rate will be K a raised to the power x, b raised to the power y, and you know ki x plus y is equal to n. That is order of the reaction, right? Itna we know. So what will be the value of K from here? The value of K will be rate divided by this thing. Okay, now what is rate? Rate is concentration upon time, है ना? So I can write concentration upon time into 1 upon. Now what is this? This is also concentration, na? And if I add them, I will get the value n. So it means 1 upon concentration raised to the power n. So put the value of n here and you will get the units of rate constant. This is the general formula I am giving you, okay? If you can remember the units, well and good. But this is the general formula. Let's say if you don't remember what will be the unit for second order or first order reaction, you can use this. Okay, just use this up, और यहाँ पर concentration raised to the power n minus 1 भी लिख सकते हैं, but this is the easy way to do it. Now let's say for zero order reaction, let me do it. Now for zero order reaction, what will be the units of rate constant? So यहाँ पर लिखेंगे concentration. What are the units of concentration? So units for concentration are mole per liter, right? And time के लिए the SI unit is second into 1 upon mole per liter raised to the power 0, because n is 0 here. Okay, for zero order reaction n is 0. Now K will be, now anything raised to the power 0 is 1, right? So यहाँ पर I'll get 1 because anything raised to the power 0 is 1. So what I am left is mole per liter per second. So it means for zero order reaction, the unit of rate constant will be mole per liter per second. Okay, got my point, students? So this is how, see, if you remember the general formula, you don't have to like rattafy this thing. You ratta nahi marne ki zarurat hai. Just try to understand what is rate constant. Okay, so how can we find out the unit? Unit is very important. This is asked in the exam. So now what you have to do is you need to tell me the units for rate constant for first order reaction. And how will you tell me? In the comment section. So now you have to comment two things. Okay, first is that question I have told you. So like write order is equal to this, whatever order you are getting, and then comment the rate constant unit for first order reaction. So first order reaction ke what you will do, you have to write n equal to 1. So n equal to 1 put karna. So it's very easy. Just give me the comment. Okay, so I'll be waiting for your comments in YouTube, and those who will be giving the right answers, I'll be responding to them. Okay, so you have to comment two answers there. All right, students, so can we move ahead now? I think this is clear how to find out units of rate constant. Again, if you are not able to understand anything, I'm again saying it, try to comment. Okay, tell me, how will I get to know? Because we are not in live class now. So you need to comment ki ma'am, I am not understood how to find out unit of rate constant. So I'll try to explain it again, right, in a much easier way. So that's what I want to do. If there is any topic you are not understanding, please do let me know through your comments. Okay. Chalo. Now let's is next thing is molecularity. So we have learned about order of the reaction, you know. Now the next thing is molecularity of the reaction. Now molecularity is again an important thing that is asked in the exam. So you must know the basic differences between the molecularity and order of the reaction also. Okay. Now like to understand the mechanism of the reaction, what do we need to know? We need to know the molecularity. So what is molecularity? Very easy. Just a minute. Yeah. The number of reacting species. It can be atoms, it can be ions, or it can be molecules taking part in elementary reaction. Okay, we are talking about elementary reaction. We are not talking about complex reaction abhi. So what are the number of reacting species that are taking part in elementary reaction, which must collide simultaneously in order to bring about the reaction is called molecularity. You know, whenever there are reacting species, how the reaction will happen. Those reacting species will collide with each other, collisions will happen. So kitni species collide kar rahi hain simultaneously in an elementary reaction, that gives you the molecularity of the reaction. Based on it, reaction can be unimolecular. Unimolecular means whenever one reacting species is involved. For example, decomposition of ammonium nitrate. Nitrite. So it will give you N2 plus 2H2O. So how many reacting species are there? Only one, ammonium nitrate. So it is decomposing to give you nitrogen and water. So it's a unimolecular reaction. Okay. Now this is something, another new term you must know. Unimolecular reaction means where the Molecularity is 1. Okay. Next, bimolecular reaction where there is simultaneously collision between two species. Okay, like decomposition of hydrogen. It's not necessary कि those two species must be different. Two species मतलब दो molecule. So यहाँ पर two HI molecules are colliding with each other. They are dissociating to give hydrogen and iodine. So it's a bimolecular reaction. Okay, so it's a bimolecular reaction. Now next we have trimolecular reactions. So trimoleculars or termolecular means if there are 3 reacting species. Okay, try to understand this. If I am having 2NO, okay, plus O2 gives 2NO2. So it's a trimolecular reaction. 3 species, 2 NO है आपके पास और एक O2 है, तो 3 species है ना, they are reacting. So it's a trimolecular reaction, means the molecularity for this reaction is 3. Okay. All right. Now students, what happens is that more than 3, the probability that more than 3 molecules are simultaneously colliding and reacting, it is very small. So that is why you will not find the reactions with molecularity 3 or greater than 3, like there are not much reactions. So what will happen then? So that those reactions are not happening in one step. Okay, we are not talking about elementary now. So I am saying ki elementary reactions में molecularity maximum can be 3. It can be more than that, but the probability is very less. So in that case, if there are more number of molecules, so the reaction will be a complex reaction, means it will proceed through a number of steps. Okay, fine. For example, if I'm having this particular reaction, how many molecules you can see? So here you can see 10. 1, 6 and 3. So 10. So it means it's a 10th order reaction. But no, it's not a 10th order reaction. It's actually a second order reaction. Okay. So it is actually showing that this reaction takes place in several steps. Now another question arises. अब अगर एक ही step हो रहा है तो उसी का जो rate of rate होगा, rate of that step, that will be the rate of the reaction. But if the reaction is taking place in number of steps, let's say 3, 4 steps or 5 steps, so out of those 5 steps, which one will be the step that will control the rate of reaction? That we need to know, na? Right? Okay. Let's say if you are going from home to school and you are 3 students, okay, 3 students, and if I tell you ki how much time you have taken to reach school, let's say first student reached in 10 minutes and second student reached in 15 minutes and third student reached in 20 minutes. So the one that reached the slowest, I will take that time ना कि उतना time लगेगा school से घर पहुंचने में, that much time will be required. Okay, that's the maximum time that is required. जब तीनों पहुंचोगे then only the class will start. Okay, then it will start. So that is the thing कि हमें slowest को ढूंढना है. We need to find the slowest step. If the reaction is proceeding in 5 steps, the one that will be the slowest. Okay. So that will be controlling the rate of reaction. Okay, let's say if there is a relay race, यहाँ पर दिया relay race competition, you know relay race जहाँ पर 4 लोग भागते हैं, like 4 people run. Okay. So how can you tell the probability of winning that race? So that will depend on the speed of all 4 of them, right? All 4 of them पे depend करेगी. But the chances to win that race, वो किस पे depend करेगा? The one that is the slowest. Okay, so इसीलिए we are saying कि overall rate of reaction will be controlled by the slowest step in the reaction, and always keep that in mind कि slowest step is the rate determining step. This thing will be asked in organic, inorganic, हर चीज में you must know. Organic reactions पढ़ोगे, there it will be asked like what is the rate determining step. So in that case, the one that is the slowest step is the rate determining step. I hope you have understood this thing. Okay. So let's say we have taken an example here. Decomposition of hydrogen peroxide, which is catalyzed by iodide ion in alkaline medium. So it's giving you H2O and O2. Now the rate equation is this. Okay. Minus D of concentration of reactant upon dt. So K into H2O2 and I also. Okay. Now here you can say that this reaction is first order with respect. It's not a second order. Now from here you will see ki 1 1 it becomes 2. No, this is not a second order reaction. It is a first order reaction with respect to both hydrogen peroxide and iodide ion. Why? Because this reaction takes place in 2 steps. Okay. So यहाँ पर एक intermediate बनता है IO negative. Then you get the product. Okay. Now which one is the slow step out of these? Yes. Now here both are bimolecular elementary reactions. You can see here. Okay. Both are bimolecular, two reacting species and elementary reactions. Now species IO negative, I told you it's an intermediate. Okay. It's formed during the reaction and consumed during the reaction only. रिएक्शन के दौरान ही बन रहा है, formed during the reaction and consumed during the reaction. That's why it's not in overall balanced equation. And here the first step, the formation of the intermediate, this one is the first step, is the slow step, and it will be the rate determining step. So it is going to be the rate determining step. Alright students, so that's why concentration of H2O2 into concentration of I. तो अब समझ में आई ये expression कहाँ से आया? From the first step. Okay. So this will determine the rate of the reaction. So from here what we have concluded is that order of reaction is an experimental quantity. It can be 0 or fraction, but molecularity cannot be 0. Of course, it's the number of species reacting, so number of species can't be 0 or non-integer. Okay, it cannot be in fraction also. Order is applicable to elementary and complex reactions. So order सबका होगा for elementary reactions and for complex reactions, but molecularity is applicable only for elementary reactions. So these are the differences between order and molecularity. Okay, don't get confused. Because for complex reactions, molecularity will have no meaning because the reaction will be taking place in different steps. वहाँ पर intermediates भी बनेंगे, everything will happen. Okay. So for complex reaction, order is given by the slowest step, and molecularity of the slowest step is same as that of the order of overall reaction. Okay, so I think this much is clear. Now students, the next important thing is the integrated rate equations. Okay, so you have already studied that the concentration dependence of rate is the differential rate equation. Okay, we'll be calling it as differential rate equation because it's not always convenient to determine the instantaneous rate, because instantaneous rate we have to draw a tangent and we need to find out the slope. Okay, so it makes it difficult to determine the rate law and then the order of reaction. So we will integrate that differential equation, and to find a relation between the experimental data, means we will find a relationship between the concentration at different times and rate constant. That will become easy, right? If we have a relation between concentration at different times and rate constant, so we can easily determine the order of the reaction. So we will be studying these for the 0 and first order reaction only. Also we have higher order reactions, but you will be learning them in higher classes. Now what do we mean by 0 order reaction? Okay, 0 order, so you know rate is K into concentration of reactant. Zero order reaction means the rate will not depend on the concentration of reactant, means it will be proportional to zero power of concentration of reactant, like this. Zero power means यहाँ पर तो कुछ होगा ही नहीं, so rate will be equal to the rate constant means, okay. So it means here this is the zero order reaction. Let's say if I'm having a reactant like it's changing to product, तो rate क्या होगा, minus dr upon dt. It will be equal to K into R raised to the power 0, since it's a zero order reaction. From rate law we have written. Okay. So you know any thing raised to power 0 is 1. So minus dr upon dt kitna ho gaya? It will be K. So from here students, of course, minus dr, or if I can put this minus on the right hand side also. Put this minus on the right hand side, okay. So it will be minus K dt. Now you have to integrate it, okay. Integration you might have studied in mathematics, so you have to integrate it. If you integrate dr, so it's just 1 dr na, so it will be r. यहाँ पे we are doing the integration of dt, so it will be minus kt, and with integration we have I as well. Now what is I? I is the constant of integration, okay. इतना समझ में आया? I hope this much is clear. Now how to find out the constant of integration? Now you know at time equal to 0, let's say when the reaction has not yet started. See this R, what we are taking is this concentration of R at any instant time, okay T. But let's say when the reaction has not yet started, T is equal to 0 pe, the concentration is R naught. R naught is the initial concentration. Keep that in mind. Initial concentration of reactant. Okay. So, put the value here in this equation. R ki jagah we'll write R naught minus K into 0 plus I. So, from here the value of I will be R naught. Now, put this value here. So, you will get R is equal to, यहाँ पे put कर दो, R is equal to minus KT plus I की जगह R naught. Okay. This much is clear. So what you can say from here is, if I want to plot this on graph, let me write it again. R is equal to minus KT plus R naught. Can you compare it with the straight line equation y is equal to mx plus c? Now on y-axis I am taking concentration of R, this one, and on x-axis I am taking time. So from here what will be the slope? Compare it. The slope will be minus k, okay. So slope is minus k, means it will be like this. This will be the straight line. And the intercept means the one that is touching the y-axis here, it will be R naught. So this is how we represent the graph. So apart from studying the rate law, you must know this thing also, the graph, क्योंकि graph के ऊपर भी questions आते हैं, okay students, questions are asked on the graph also. So from here you can find the value of rate constant. So it's like this na, R is equal to minus KT plus R naught. So you can say KT is equal to R naught minus R. This is what you can say. So from here K will be equal to R naught minus R upon T. So keep that in mind. This is the rate equation or rate law for the zero order reaction. For rate constant we have found. So you know zero order reactions, they actually occur under special conditions like enzyme catalyzed reactions or the reactions which occur on metal surface. Like decomposition of ammonia on a hot platinum surface is a zero order reaction. Keep that in mind. Okay. Like if I am talking about this reaction. So it's 2NH3 decomposition of ammonia on a platinum catalyst. So okay, but here the rate of reaction is, it's a zero order reaction. It does not depend on the concentration of ammonia. Why? Because platinum is acting as a catalyst here. At high pressure, metal surface gets saturated with the gas. Okay. So if it gets saturated, further change in reaction conditions is unable to alter the amount of ammonia. So that is why the rate of reaction is independent of concentration of ammonia. Okay. Similarly, thermal decomposition of hydrogen iodide on gold surface is also example of zero order reactions. You must know one or two examples as well. That's why I'm discussing. Okay. Now let's see the integrated rate equation for the first order reaction. A first order reaction में क्या होगा students? If I am having this reaction to product, so the rate will be, please keep on noting it with me. Here we are discussing the derivations also. Okay. Exam mein of course derivations will not be asked. But if you know the derivation, you will be easily able to remember the result. Ki how that result is there. So इसीलिए that's why I am explaining you the derivations also. Now for first order reaction, it will be K and R ki power 1. Okay, for zero order it was 0 na. Here it's R raised to the power 1. So we will take the R terms together. dr upon R is equal to minus K dt. Again we will integrating both sides. So you know 1 upon x dx की integration क्या होती है? It is log of x. So here it's 1 upon r dr. So I will get log of r. These are the rules of integration. Okay. So that you have to remember. And again k dt की minus kt plus I. Constant of integration. Up, how will you find out the constant of integration? Again, when t is equal to 0, r will be r naught, right? Which is the initial concentration, right? Initial concentration of the reactant. So you can say log r naught minus k into 0 plus I. So from here the value of I will be natural log r naught. Clear? I am telling you step by step. If you have any doubt, you can let me know. Alright, now we will substitute the value in equation number 1. Okay, just a minute. Yes. So when you substitute the value in equation 1, what you will get? You will get natural log r is equal to, यहाँ पर लिख सकते हैं from equation 1 minus kt plus log of r naught. Okay, just a minute. Now next step. Okay, now you have put this value. Now like rearrange this. So it will be log r minus log r naught is equal to minus kt. Now you must know another formula, that is log a minus log b is equal to log a upon b. Okay, that's why I'm writing these formulas, because these are the mathematical rules. So it will be log of r upon r naught. So you, in physical chemistry you need to remember these things also. Okay, minus kt. So from here what you will say, it will be k is equal to 1 by t minus यहाँ पे लिख लेंगे log of r upon r naught. Now students, I want to remove this minus sign. If this is log a upon b na, so it will be minus log b upon a. Keep that in mind. Okay, so I can like reverse it. I will be writing 1 by t log of R naught upon R. R naught is the initial concentration and R is the concentration at time t. So this is what we got the integrated rate law for the first order reaction. Okay. Fine, students. Now this is the integrated rate law for first order reaction. Let's say if I am having two conditions, okay, that is at time t1, the concentration is R1. So from here what I can say is, from this equation we will be writing, let me show you this one, okay, from this equation. So log of R1 is equal to minus KT1 plus R naught. R naught is the initial concentration, log of R naught. Okay, similarly at T2, let's say the concentration is R2. So from here, natural log R2 will be equal to minus KT2 plus log of R naught. This is what we have already determined. Okay, R1 and R2 are concentration of the reactants at time T1 and T2. Okay, so let's say it's 2 and 3. Subtract. Now what you will be doing? Subtracting 3 from equation number 2. So log R1 minus log R2. Okay, you have to subtract it ना. So subtract करोगे ये terms cancel हो जाएंगे. So minus KT1 minus KT2. Okay, because we are subtracting it. So log of R1 log of R2. So यहाँ से आप लिख सकते हो, दे पॉजिटिव हो जाएगा. सो के T2 माइनस T1. ओके, क्योंकि ये बन जाएगा माइनस KT1 प्लस KT2. सो फ्रॉम हियर यू कैन से के T2 minus T1. Okay, if any confusion. So again log A upon B we will be applying. So it will be log A minus B is log A upon B is equal to K T2 minus T1. So from here K is equal to 1 upon T2 minus T1 log of R1 upon R2. So now you have got another expression where if you are given two different concentrations at two different times, then how can you find out the rate constant? Okay. Fine, students. So if I want to discuss the graph here, this is the relation that we have got. Okay. So from here, this one. So students, I have like told you two relations, but if I want to draw a graph, what we will be doing from here. So this was there na, log of R upon R naught is equal to minus KT. Okay. So I want to remove this log. If I want to remove this log, I need to take anti-log. So anti-log and log will cancel out. So here I will be getting R upon R naught. And when I take this anti-log, it becomes e raised to the power minus kt. So from here I will say that R is equal to R naught e raised to the power minus kt. Okay. So from here you can plot this graph from the first equation. Alright, that is log of R naught is the intercept and minus k will be the slope. Okay, negative slope is there from here. Okay, and this is another graph if you want to write it in the form of log of R naught upon R. Fine, students, like I have told you, it is K1 upon T, natural log R naught upon R. Okay, so from here, if you want to remove this natural log to the base 10, so it will be 2.303 log to the base 10 R naught upon R. This was the equation, right? So from here you can say log of R naught upon R will be KT upon 2.303. So from here we have got this graph. Okay. Intercept is 0. I am taking it as y. Okay. So this is x and k upon 2.303 will be the slope. Okay. Let me write log R naught upon R. M is k upon 2.303 and x is your time plus c is 0. From this equation, we have plotted these two graphs. So these are the two graphs, students, that you need to remember for the first order reaction. Now next is half-life of a reaction. This is again important. Again, you will be getting a lot of questions from this topic. Okay. So again, what we have to remember is the formula. Okay. We have to remember the formula. So if you remember the formula, you can easily do the questions. But how that formula is derived, we will be seeing. Now, what do we mean by half-life of the reaction? Half-life of the reaction is the time in which concentration of reactant is reduced to 1/2 of its initial concentration. At what time the concentration of the reactant is half of the initial concentration. So we represent it by T half. Now we will do it for a zero order reaction. So what is the rate constant? We have just calculated K is equal to R naught minus R upon T. So students, you know, at T half means at half life, R will be equal to in half of the initial concentration, right? R naught upon 2. So put these values here. K is equal to R naught minus half of R naught upon T half. Okay. So T half ko we will take on the left hand side. So R naught minus half R naught will be half R naught only upon K. So what does it becomes? It becomes R naught upon 2K. So this is the half-life for the zero order reaction, and you can see that it depends on the initial concentration of the reactant. Okay, it is directly proportional to the initial concentration of the reactant and inversely proportional to the rate constant. Okay, so now for first order reaction, what will be the rate law? 2.303 upon T log R naught upon R. Remember this equation from here. KT is equal to 2.303 log R naught upon R. Here, this equation, okay? Alright, so again at T half, R is your R naught upon 2. Alright, so put the values here. K is equal to 2.303 upon T half log of R naught upon 2. So R naught will be cancelled out. This 2 will go up. So it will become K 2.303 T half log 2. Okay. Log 2 is 0.3010 students. So यहाँ से आप लिख सकते हो T half is equal to 2.303 into 0.3010, which is log 2 upon K. So from here it will come out to be, when you solve it, it will come out to be 0.693 upon K. Now what are you able to see from these two expressions, students? This is important, that for this zero order reaction, the half-life depends on the concentration of the reactant, but for the first order reaction, it is independent of the concentration. Can you find any concentration term here? No, right? So it is just 0.693 upon K. So it is independent of concentration of the reactants. So you have to memorize these two formulas. How we have calculated it, I have shown you. Okay students, so this was about the first order reaction and zero order reaction which we have studied and all the basic things. In the next lecture we'll be talking about other factors that are affecting the rate of reaction like temperature dependence. We'll be also learning what are pseudo first order reactions. Okay, so for this revise the derivations and write the formula separately. Derivation तो करनी है but make a flow chart, make a separate sheet for the formulas which you have to memorize for the exam. Okay, and again let me remind you, if you are having any doubts or any problems, please do comment in the comment section, and I have given you 2 questions, so you have to give me answers for that 2 questions in the comment box. Okay, so I'll be waiting for your answers and other comments also where you'll be discussing your problems. Okay students, so see you in the next lecture. Thank you so much.